Hey Twitch. People are still getting food, sorry. We'll start in a couple minutes. All right, I'm going to go ahead and get started. So as a reminder, the sprint tournament submission deadline was 18 minutes ago. So if you haven't submitted, it's too late. That's good. We're going to stream that tomorrow for much of the day, probably starting around 3. Submissions will open back up sometime after the sprint tournament, so you can like keep uploading new bots and stuff. But they are frozen for now while we like make a copy of everyone's code so we can run it for the tournament. Other announcements include we fixed a lot of bugs, made a bunch of improvements to the client, so make sure you Gradle update and build and stuff. Logs should be working a little bit better now, yeah, lots of stuff. Cows, oh yes, important specs update. Cows now move symmetrically. So the map itself obeys the symmetry, and the cows used to be just random, which could be unfair if a cow stumbles upon your HQ very early. But now the cows move symmetrically, as you can see in this game. They obey the map symmetry until they run into, until like something affects them that is like not part of the map. So either robots from one of the teams or something like that. But yeah, so those are symmetric now. Okay, and today we're going to talk about how to organize your bot into more than one file. We'll talk about some Java things like inheritance and polymorphism and other keywords, buzzwords. But yeah, so I've gone ahead and started this already. So let me show you what's the deal. There are many new functions. So first of all, there's this robot class. So the general plan is going to be robot player.java should be pretty simple. It just has one switch statement, and then depending on the type of robot, it creates one of our new classes for that type, and then says run or like take turn. So the base class that we're going to have for all of our robots is this class robot. For things like buildings, it'll extend robot. So we'll talk about that in a second. But this is similar to classes in other languages, just like a little bit more extreme. So in Java, every class has to have a constructor, which is this. It has the same name as the class, and this is just the function that gets called when you say something blah 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 new robot or new building. So that's all the constructor is, and it just does the initial setup if you have any to do when you create the class. And then we are defining this take turn function for every robot. So every unit or every thing in the world that is an instance of this class robot, so it was created using new robot or similar, is going to have this take turn function, which right now just increments the turn count and says I'm a robot. And then we'll talk about some functions later. So this is our base class. It has, I'll talk about the communications and navigation in a second as well, but at its core, it just has the robot controller, RC, and a constructor and the take turn function. So a building extends robot, and so what extends means in Java is that it inherits all of the fields and constructors and everything from that class automatically. So despite, so if this function here didn't exist, all buildings still have a take turn function already. They inherited it from robot. So if you were to make a new building and then you were to say like whatever the instance is dot take turn, it would call this function in robot because there isn't one in building. So it would increment the turn count and print I'm a robot. If we do choose to implement the take turn function, then when you create a new building and you call take turn, it'll run this function instead of the robot function. But if we still want all robots to do the same thing at the beginning of every turn, we can do that with super.taketurn. So super is a Java keyword that refers to the super class, and we actually use it twice here. So in the building constructor, we call the super constructor. So this is kind of like saying new robot, new robot R, where R is the robot controller. And so this will do, every building will automatically do whatever setup is in the robot constructor. But if we want to add, if we wanted to add more for like just buildings but not units, for example, then we could add that here. So like building specific setup here. And so yeah, so this super is going to say, well, whatever the default robot behavior is, or the default robot setup that we want all robots to do that. But then you can also do some other stuff. And same thing with the take turn here. Okay, and then we have HQ, which extends building. So HQ extends building means it inherits everything that building has, which inherited everything that robot has. So if the HQ.takeTurn function were undefined, so if this didn't exist, and you made a new HQ, and you said HQ.takeTurn, it would do the building's take turn. So it would do robot take turn. So it would do this, turn count plus equals 1, and print I'm a robot. And then it would print I'm a building, and then that would be it. But as it is, the take turn function calls super.takeTurn. So it will do that. It will run this function, which will run this function. But then it'll do other stuff. So it'll print I'm the HQ, it'll send the HQ location, and it'll try to build some miners. And we can see that the HQ actually has an additional field up here. So all robots, and HQ is a robot because it's a building, and buildings are robots. So all robots, including the HQ, know about RC, comms, nav, and turn count. So the HQ can use all of those things, and in fact it uses turn count right here, despite turn count not being defined in this file. That's the only instance of turn count in this file. And in fact, turn count never even appears in building, but because HQ extends building, extends robot, this turn count variable and its update at the beginning of every turn here, that all gets inherited, which is another Java keyword, inherited down to the HQ. So the HQ can use turn count and stuff like that. If we wanted to have some building specific fields, we would put them here, and then the HQ would get that also. But so far we don't have any of those. Okay, and so how are we actually going to use all this stuff? Back to the setup part in robotplayer.java. So robotplayer.java is going to get a lot shorter over the course of this lecture. And the core of it is now this gigantic switch statement right here. So let's look at this. Okay, so this is the run function, the one that every robot player needs to have, this run function. And this is what the engine calls to execute the robot. So now our run function, it used to say, case HQ, do turn or run HQ, case miner, run miner, etc. Now we are going to have a robot, so we don't know what kind of robot, but because the HQ is a robot, we're allowed to say something like this, where we say we can say robot me equals new HQ. And at first this looks like it should be a compile error because these are not the same class. We're telling the compiler that me is of type robot, and we know that HQ, this is a constructor. It's going to return something of type HQ. But this is where Java inheritance saves the day. HQs, because they extend buildings, which extend robots, are robots. So you can actually, you can do this. So since the declared variable is of type robot, and HQ is of type robot because it inherits it, this is legal. What's not legal is if you were to say HQ me equals new robot, and you also could not do building me equals new robot. This is not allowed because not all robots are buildings, and this me object is going to have the type that is declared in front of it. So if with just this line, me is going to be a robot, and it will yell at you if you try to use a function that robots don't know about. Or alternatively, if you had building me, then you would be allowed to use functions that buildings know about. But since it's actually a robot, like that would not be okay because there could be some function that the building knows that the robots don't, and that's why it gives you a compile error. So in this case, an example of this is take turn. So all robots know how to take turn, but where's the HQ? But the HQ has this extra function. Oh, no, it doesn't. Buildings have an extra function? Oh, we haven't filled it in yet. Eventually, the HQ is going to have an extra function that not all robots know. So you could not use that function in general if you declare a type robot. That was kind of convoluted. Anyways, so this is a new robot. It starts out as null because we don't know what type it's going to be yet. Then we do this big switch statement. So if it's an HQ, we create a new HQ. And for the rest of the units, we haven't created classes for them yet. So I've just made them, for the time being, units and buildings. And so what's great is since all of these things, the HQ, unit, building, and eventually like the minor class, the design school class, etc., they all are robots. They all inherit from robot. So this is a valid assignment in all cases. Because me is a robot and these are all robots, so you can do that. Also, all robots know the take turn function. So what's really cool about this is that for the rest of our function, which is very short, it's just try me.takeTurn and then clock.yield. That's the entire rest of the function. What's cool is that this function doesn't need to know what type me is, because it knows it's a robot and all robots know how to take turn. So when you say me equals new HQ and then you say me.takeTurn, Java will call this take turn function in the HQ class. When you say me equals new unit down here and then you do me.takeTurn, Java will call the most specific take turn class. So, oh wait, that's not unit, that's util. Unit. So that will call this take turn function. If this take turn function didn't exist, and you said robot me equals new unit, like we do, and then you do me.takeTurn, it'll check unit. There's no take turn here, so it'll use the robot's take turn, and that's totally valid, and that's exactly what we want to happen. And so this is called polymorphism, which is like one of the big things that Java is known for and can be really convenient for cases like this, where all robots know how to take turn, and you're going to make lots of different kinds of robots, but you want them all to take their turn, and you want the specifics of how that's going to work to be inside each class. So now, like before, when we were editing the code, it was like hundreds of lines, and we had to control find, run miner and run landscaper and whatever, and it was like a big mess. Now, all of the stuff that only the HQ does goes in the HQ file, which is like pretty short. Only the things that all buildings do goes in the building file, which should say pretty short. And then only the things that all robots do, like take turn and like TryBuild, so like enough different types of robots, both buildings and miners, have to build stuff that we can have this function as a robot-wide function, so that those all inherit it automatically. And so this thing is called polymorphism, and it's really convenient because it allows us, by the end of this lecture, the robot player.java file is going to end on this line. And the only thing in it is going to be this big switch statement that creates the appropriate unit and then says me.takeTurn, clock.yield. That's it. And then all of the details about the different types of units can be just in those files related to those units. And likewise, so actually, does anyone have questions about that so far? Because polymorphism is a little weird, so. All right, cool. So similarly, we would like it so that we can have all of our communications code in one place and all of our like complicated navigation functions in one place, right? So all robots have a communications object, and this communications object is of type communications. So this is where all of the communications code is going to live. And the robots don't have to care at all about how it's implemented or anything like that. It just needs to be able to access these high-level functions like send HQ location or get HQ lock from blockchain. So every robot is going to have a communications module, and it's created here in the constructor. So right when the robot is created, it creates a new communications object, and then that object, you can use the functions of that object to do all this good stuff. So as an example, again with the HQ, we have the comms are set up right here, and then that's it. They aren't used in the rest of robot because we haven't decided yet that there's like one communications thing that we want all robots to do at the beginning of every turn. But because the HQ inherits all of these fields, the comms, nav, and RC, and turn count, and because it uses the super constructor, or the super keyword in its constructor here, all of that stuff will automatically be set up for the HQ, as it will for all robots. And the HQ can use the comms right here. So in take turn, comms isn't declared again. This is the only place in the entire file that comms exists, but we can use it because the HQ is a robot. So we can use comms.send HQ location just fine, and turn count just fine, even though they're defined, or they're initialized up here and defined over here. All right, has anyone lost yet? Okay, cool. So similarly, with navigation, there's, where'd it go? So with navigation, right now our navigation is pretty simple until later this week. So we just have our try, move, and our two go-to functions. But now every robot can just have a nav module. So right here, gets initialized just the same as comms right here, and then any unit or anything can use nav. I guess technically nav should be a unit thing. That's cool. Okay, we'll move it there. Let's do that right now, because only units can move around, which is why I made the distinction in the first place. So let's go ahead and move this to where did it go? Util and unit are messing me up. Unit. Okay, so units, so already you can see there's some specialization. Only units really care about the HQ location because buildings couldn't act on it anyways. And now we're going to say they also have a navigation module, nav. So let's go back to, let's keep pillaging robot. Okay, so we don't need it to be set up in the robot constructor anymore. We can have this be set up in the unit constructor. So the unit constructor will call the super for the robot. So this will execute all of the like communication setup and stuff like that. And then it'll start, or then it'll initialize this different unit specific thing, nav. And then all units can use nav. And then also all units. So I went ahead and like copied the find HQ function into this because again, only units really care about the HQ. But all units are going to care about the HQ. So it makes sense to put this function at the unit level instead of at the like minor level or the landscaper level. And so this is going to let us sort of sort our code into the places where it really matters and not have, but still not have to duplicate functions and like copy and paste the same code in multiple places. It's just sort of like a logical separation of concerns. Okay, so let's just make sure I didn't break anything while I was editing stuff by compiling the bot. And then we can continue. So right now, I've only partially split out the current functionality of Lecture Player into the new organizational structure. So I've only copied over the HQ itself. The miners don't do anything anymore, and none of the other, and they don't build any other units. So let's just check that the print statements are all saying what we expect. So on turn 1, the HQ prints. So in take turn, remember we like take the turn of the super and then take the turn of like whatever unit it is. So when the HQ, when it says me.takeTurn for the HQ object, the HQ will call super.takeTurn, which will call super.takeTurn and print I'm a robot. And then when that's done, the building level takeTurn will print I'm a building, and then the HQ level takeTurn will print I'm the HQ. So this is how we expect it. The minors, oh wait, the minors don't say anything yet because we haven't created them. So let's do that next. So when we want to create a new class, let me just pillage the unit.java. So it needs to be in the same package, and that's the reason that I haven't had to import robot here. So like, robot isn't a Java keyword, right? It's not even a Battlecode keyword, or I mean it kind of is, but it's not. It's like robot type or robot player or whatever. The robot that we're talking about is not being imported here. It's because it's in the same package as this robot file, both package lecture player, that it's sort of automatically imported and available to everything else in the package. So we want to take this kind of stuff, and we'll make a new file. And I need to change this to 4. And then what we'll do is we'll say we want this to be a minor. And minors don't extend robot, they extend unit, which extends robot. So that it has the like nav and HQ lock and stuff. So we don't need these fields anymore. We don't need to set up a navigation. That's all handled in the super now, because super is unit. And then we do need to override take turn, because we're going to have some minor specific stuff in there. And then the name of the file always has to match the main class. So we'll save this one as minor.java. Sorry, it's slow because streaming and the client. All right, so right now our minors don't do very much, and in fact don't even get created. So let's just create them first. So now minors can be, instead of a new unit, a new minor. Exciting. Okay, and then let's take run minor and move that into the minor. So update unit counts is probably the kind of function that we might want for all robots. So let's put that in. Oh, wait, this is for communication. Sorry. Yeah, update unit counts is a communications function. So let's put that in communications, and we'll delete this function and put it in here. So now what we probably want to do, or what we're going to want to do, is to make this return the number of units, because we don't want the communications module to have to worry about keeping around state about the game world or something like that. We want the communications to only worry about communications. So what I'm going to do is have this return a number of, so the eventual way that we'll want to do this is to just have it return an array which says like the number of additional units of each type. Right now, because it's only counting design schools, we'll just take a shortcut and say, let's say get new design school count. And again, this is like a function that you should look at and be like, oh, maybe we can extend this to be more general, and you're right. So now we'll take this and just say count. And then we can make this count variable at the beginning, int count equals 0, and then return the count at the end. So this is, it just changed a little bit. Instead of directly adding the number of design schools to some variable, it's just going to return, oh, not return 0, return count. Return the number of additional design schools for the current round, or the previous round, I guess. so now that we have that, what we can do is go back over here. And did anything else use the update unit counts function? Nope, just the miner. Okay, so we'll take the run miner, this big run miner function, and we'll remove it because it's going in miner.java now. Okay, so now we can finally fill this take turn with something interesting. So what we could do is we can say, all right, only miners are going to care about the number of design schools right now because no one else can really do anything about it anyways. So we'll say num design schools starts out as 0. And then what we can do is comms. And so again, comms is never mentioned in this file, but because miner is a unit, which is a robot, and robots set up comms, we have access to it, and we can say comms dot, what did I just call the function? I forget. Comms dot get new design school count. So we can take this, and we can put it here. Oh no, put it here. Okay, so comms.getNewDesignSchool design school count is going to return the delta, so we just need to say num design schools plus equals that. Okay, so now that's taken care of. The number of design schools will still be up to date. We need another update soup locations, or we need another function that is uses the communications. But updates some local state. So we're going to have to go back to miner, or back to robotplayer.java, and take some more code from here. So the num design schools is also no longer in use, so I'm going to delete that. And then this soup locations is something that only miners care about. So we'll put that in here as well. And this doesn't need to be static anymore. Okay, so now we have our soup locations array, but we need to edit the soup function. So the update soup locations. Okay, so this will again go in communications because this is communication related. So we'll take that away and put it here. But we don't want it to change local state. So instead, we'll have it return an array list of map locations. So array list of map location. And then we can create a new one. I wonder if, nope. Array list of map location, soup locations. And so this will start out empty. Array list of map locations. So this will start out empty. We'll add some stuff to it, and then we'll want to return this. Am I in the right place? We'll want to return this array list. So we'll say return soup locations. Okay, so now when we go back to miner, we can do, I think there's an ArrayList Merge function, but I forget exactly what it's called. So we'll go back to our handy dandy documentation named Google, and Google Java merge ArrayLists. Hopefully. Look, no hands. It's so slow. Java merge ArrayLists. Okay. And hopefully, I should really preload these web pages, sorry. Okay, add all. Great. So we'll go back here, and we'll, I actually thought of an easier way to do this while the web page was loading. We could just pass the soup locations here. Since it's an array list, we're going to be passing the exact object, and this function could just edit the exact list for us. So that's even more convenient. So we can give it this soup locations thing, let the communications module edit it in the appropriate way, because we also don't want duplicates, but we don't check for duplicates. So where did we check for duplicates? That was supposed to happen somewhere. Contains. Oh, it's when we're broadcasting a new one. Right. All right, that's fine. Well, we should improve this function so that it can't include duplicates. But
kind of basic. In Java, when you go and pass something, if you go and modify that within there, does that modify the original, or does it modify a copy?
Yeah, so good question. The question is, when we pass the soup locations array into here, will it modify it, or will it make a copy and then modify the copy, which is not as useful? And the answer is it depends on the type of data. So integers and strings are not changed. Array lists and arrays and things like that will be changed. So this is why, I don't know if you noticed in the very beginning of the tournament, the blockchain, despite its name, was mutable. If you got a block, you could actually edit what was in it, and that would edit the blockchain. And this was because we forgot to create a copy of the array, and we just gave you the array, and then since we didn't make a copy and we passed it to you, you could edit the original, and it would edit the original inside the engine, which is not what we wanted. So now it makes a copy. But yeah, so we'll, I'm going to take this. So right, so we're going to take the soup locations thing and pass it to this function so that it can edit it for us, because that's more convenient and more bytecode efficient anyways, and no longer return it. So now it's the same as before, just adding to the soup locations. And the reason that I wanted to do it this way is because it's a lot more inconvenient to check for duplicates when you have two lists. We don't want to get a list of soup locations back and then have to go through it again to see if there are duplicates. It'd be nice if we could just check if it were a duplicate right here. So I'll put it to do, don't add duplicate locations. Okay, and so that's why in this case it's more convenient to have the state being edited in here. But because this is a minor specific thing, the actual variable is sort of stored in the minor, and this is just a convenient function that helps us edit it. Does anyone have questions about that setup? Because it's a little bit different than the one we just did. Okay. All right. Finally, check if soup gone. So this is definitely a minor specific function. So we'll go over here and find it, check if soup gone. So nothing else uses this. I'm just going to go ahead and delete it and move it to the minor. So we'll go here and we'll scroll down when it lets me, and then we can put this over here. So you may have also noticed that I'm removing static from all of these, which is because the way that we're creating these objects is we're actually creating an instance of a robot and then doing stuff with that robot. So it doesn't have to be static anymore because it's not a class-wide variable. It's acceptable for it to just be instance functions. And I happen to know that I think static variables are a little bit more expensive bytecode-wise. So given the choice, we can make everything non-static now. Because we're actually creating an instance of the object as opposed to saying class dot do something. It's some instance of a class dot do something. And we'll see the difference when we get to util.java, which is a utilities class that I've made. And that has a lot of static functions because you're not going to actually make an instance of util. You just have it to sort of have convenient, like any utility functions that aren't really like editing state or anything like that. It's just sort of like managing map locations and directions and stuff like that. We can put that in its own file as well, so it doesn't sort of clog up other things. Right, so anyways, we got this check soup if gone thing. It's no longer static, and the miner should now be able to use that function. And again, only miners care about checking if the soup is gone, so we'll leave it in miner.java. The other thing that we need is this broadcast soup location. So this is going to be a comms function. Oh, this is also a comms function, I forgot. So comms function, broadcast soup location. We better move that in. Broadcast soup location. Soup. Okay, great. We'll take this and we'll move it to here. And so this comms thing, oh, we also don't need these to be static, I think. So we'll use this now, and this actually doesn't need any modification. It's just now a function that's available to any instances of a comms object. So that's great, and we're good to go there. What's the next piece of miner that we need? Just TryBuild, but fortunately we already put this in robot.java down here because many types of robots need to be able to build stuff. So this is great. We can just edit this TryBuild function for one of them, and then it'll come true for all of them. So for example, if we wanted TryBuild to try harder and like try many directions, like prefer the direction it's given but try many directions if possible, we could do that. So we could try to build, we could edit it once right here, and then the building code for all of our robots that build things would automatically get the upgrade of trying multiple locations, which is why you only want to write the same code in one place, so that if you improve it, it improves everywhere. So great, TryBuild is good, and I think it's just random direction left that we need before we can actually run this miner, and nav.goto instead of goto. So random direction is one of those utility functions that I was talking about. So is that the only, yeah. So I'll show you, I'm going to edit it first and then show you why this is how it is. So the utility class right now doesn't have very much, but this is where we're going to have all of our random things like get a random direction or like rotate a direction X times or add 15 to every map location or something. So we can take random direction here. So we can take this function, and this is sort of a general utility, so we will move it here to util. And so now anything can call this random direction function, and again it's actually going to stay static this time because it's a class function. So with the individual robots, what we did was me.takeTurn, where me is an instance of the robot type. For utilities, and that's why takeTurn is not static. For utilities, since they're all static, the way that we're going to refer to those functions is with the class name .random direction. So instead of an instance of the class, we just use util.random direction. And that invokes the static functions. Great. So there's almost certainly an error somewhere, so let's find it. And then see if our miners do this thing that they used to do, which should be to like go and find soup and then bring it back to the HQ. So let's run this. Great. Oh, HQ, okay, goto is missing, right, because we moved that to nav. So since everything's on the same file, I can't just like use whatever function willy-nilly. I have to say where it came from, which is a blessing that it doesn't have to be in the same file, and a curse that I have to remember. So go-to is used just these 3 places. Okay, so we'll add a little nav dot here, because we moved all of the navigation functionality to the nav thing. The sanity bump is well worth the 4 characters. Okay, great. So now, the try mine, of course, I forgot that function. So this is another function I forgot to copy over from robot player. Again, this is a thing that only miners need to care about. So we can just remove it and from robot player, and no one else needs to know it even exists. So this is miner specific. Just delete it and put it down here. Great. It doesn't need to be static anymore, and in fact can't be static anymore, would get errors. So great, we have that. And maybe I'll preemptively read the other errors so we can see if I forgot another function like this. Oh, try refine. Forgot about that one too. Good. Another function that is miner specific. Oh, it's right here. Nice. Okay, so robot player.java is already getting much shorter. No other robot needs to worry about these kinds of things at all. Oh, I forgot the static. Sorry, streaming. Okay. All right, no more static. And let's go back and see, is there anything else? Oh, I did not import ArrayList. That's important. So I'm actually now going to, just so that I don't have to import ArrayList everywhere, I'm going to put it in the util function and import util.java, which is a trick so that I just don't have to copy and paste it everywhere. So we'll say robotplayer.java. What does this have? Math and ArrayList. We might as well just take both of those, put them in util. So we can do this here, and then if I explicitly import util in robot.java, I think I'll get everything else. So if I say import util, this should get us array lists everywhere. And so sometimes if you only use something in one place, then you only want to import it in that place, just like for good style and oh, whoops, I forgot a dot. You only want to import it in one place, but I have a feeling we may want array lists in many places. So we might as well get it everywhere now. Oh, I was wrong. Or I imported util wrong. Okay, that's why. All right, forget it. I take it back. We only use array lists in one place, and I don't want to debug this online. So we're going to import it in Miner. Yeah. Great. I owe you an explanation for imports next lecture. What do we change here? Yeah. And then Miner. Okay. Just to import array lists and move on. And let's see. Chances are I probably forgot a game action exception somewhere or something like that too. Cannot find symbol array list. Oh, there are also array lists in communications. Okay. So already we have to import it in two places. So I will I'll figure that out offline and tell you next time. But now I think that's the last error, and we should see miners doing their previous semi-intelligent behavior. And let's just look at the logs to confirm the polymorphism stuff again, just for fun. Whoops. So if I take this step 1 here, and then the next step, great. So we see team B is saying, I'm a robot, I'm a unit, and we didn't put a print statement in the minors take turn. But these are minors, and in fact, they are robots and units, which is exactly what we want. So let's watch them, and wow, they're gathering soup, they're doing indicator lines, all the things that good miners should do, bringing it back to the HQ, amazing. Oh, that's, okay, great. So our miners are now behaving how they behaved before, but it's way more organized now. So even though the bot didn't get better, life got better. And now we have miners doing intelligent things. So that's fantastic. We'll have to look into those exceptions later. Okay. So, well, wait, we should look at them now. Okay, so nav has some null pointer exceptions. Let's see why that would be. It's in navigation.goto in the miner take turn. It may be, yeah, let's see. So, if I were using IntelliJ or Eclipse, I could use the fancy debugging tools that we showed on Friday, which if you haven't seen that lecture video yet, it's pretty short, it's like 20 minutes, well worth watching, great quality of life improvements for debugging things like this, where apparently we're sending goto something undefined, possibly the HQ location. I wonder if that's it. So, or maybe util.random direction. Hard to say. Let's see where it says. Come on. Okay. Yep, this is in, okay, so this is in take turn, and this is in which version of navigation? Go to, okay, line 29 and 39. So it's doing the one where you pass it a location. I'm guessing the location is null. And so that's what our problem is. So let's just do a quick check for the util.java. This is returning something that's hopefully not null, but we can check. Oh yeah, maybe this is not what we want. Okay, so let's see the old-fashioned debugging way. What's undefined here? So at the end of the turn, we'll just system dot. Oh, we should print it at the beginning because there's an error. So system.out dot print ln the HQ location, and we'll print out a random direction also, just to see if that is undefined. So util.random direction. Okay, and let's just do this at the beginning. So system.out.println non-fancy debug. Okay, so let's see what that says. Again, I encourage you to not debug this way. The reason that I'm doing it is because my laptop is slow enough streaming and running the client all at once, and IntelliJ and Eclipse are kind of resource intensive, so everything except debugging is way faster not using them while streaming, but alas, then we get bugs. Okay, so as soon as the first miner prints something, we should probably have an answer to our question of what is null. And great, so the game is running. Let's step once. well, HQ location should be null on the first turn, and it should not be null on the second turn. But it is, oh, for that miner. Let's just look at one. So we'll look at this miner, and it's still null. The HQ location is null for all of the time, despite it being next to the HQ. So that answers our question. Great, we'll take a look at HQ lock. Okay, so the HQ location is managed in unit.java because that's what, oh wow, this is a great example. Okay, so, I planned this. So HQ location is managed in unit.java, right? Because all units probably want to know where the HQ is, and buildings probably don't care. So all of the logic about finding the HQ and stuff like that is in the unit folder. So when we have problems with that, we can look in here and we can see that take turn is never calling find HQ, which would explain why the HQ isn't being found. So we just have to find HQ here, and we just fixed a bug for all unit types that extend, or all robots that extend unit. So that's amazing. We can change the code in just this one place, and like it helps all of them. So great, now all units will actually find the HQ. The miner doesn't have to worry about the HQ location being undefined because that's handled by a different file. So we can keep all of the miner only stuff in this file and all of the unit specific stuff in the other one. And if we run this game again, then we should see fewer exceptions, hopefully none. Or we might see nothing at all. All right, go to the logs. Okay, so now if we take a look at this miner, the HQ location is known. That's great. And if we watch the rest of the game, we can see them doing their soup thing, bringing it back, finding more soup. All good miner behavior. So that's great. We can watch them for a little while if we want. They build design schools, swarm intelligently, amazing. They can always find the HQ now as well, which is good. The problem is that we have not implemented the design school count correctly, evidently. So let's take a look at that. So we'll go here and check out the miner again, design schools. Okay, so we have the number of design schools. It should be updated every turn by the comms get new design school count. So let's go back, communications.java, design school count. So let's make sure that they're printing heard about a cool new school. Oh, the problem is design schools are not broadcasting their existence. The communications are fine. It's that we haven't copied over the design schools yet, of course. Okay, great. So miners are done. They now do all of the same behavior as before, and this is actually a design school problem, which is what we can get to next. So let's commit our progress. Wow, that's a lot of changes. Okay, get if. I'm going to add a -w flag to ignore white space, which is very convenient. So let's see what changed. Building specific setup, importing array lists, moving all the design school stuff into communications, the soup locations. Great. Removed nav from all robots because it's a unit specific thing. And removed a ton of stuff from robot player, so that's good. We need that to be empty soon, or almost empty soon. That's all robot player edits. And then unit.java, we added navigation, we added finding the HQ, added the random direction stuff to util, so great. We can say git commit -am. What? Something happened. Okay, git commit -am, move more stuff to comms and util, implement miners. Great. Or sorry, I'm using my shortened version, but git push. Okay. All right, so we've pushed all the updates. Great. And now it's just the rest of the units. Because they're not that different from the miner, I'll just like do these off. I'll do most of the others offline tonight. But there was one more interesting example, I think, which was, where is it? Oh yeah, so in robotplayer.java, we have not implemented anything for evaporators or refineries or net guns at all. So like this run refinery thing is just empty. And now instead of having to do a default action like this, like run refinery, run evaporator, we can just delete both of these, and we can make, for future use, we'll just make a evaporator class, and it'll be completely empty because it'll just inherit the default behavior from buildings until we decide to do something else with it. So I'm just copying a bit from miner. Actually, I'll copy from HQ because that's more similar. So we don't need much in our evaporate. We'll do the evaporators first. Evaporator. So we don't need much in here, and we don't even need a constructor. If you don't provide a constructor, it will just use the default, which is that of the superclass. So we can remove pretty much everything and just have an empty class definition here for evaporators. And so now if we go back to robotplayer.java, we can update this to say new evaporator. And then what should happen is, well, we don't create any evaporators yet, but it should compile just fine, and it shouldn't care that evaporator doesn't override the try_mine function or even have a constructor because it inherits it from its parent building. And if we did create evaporator, class evaporator cannot be, did I not import the right thing? No arguments found. Oh, right, sorry, the only default constructor is the empty superconstructor, so we still need to write the same constructor as before, but we don't need to implement take turn or anything like that. So we can go evaporator, and then we just have to say public evaporator robot controller R, and then super R. So yeah, so this is all we need. We don't need to implement take turn or anything. It will just do the default building take turn, which just prints I'm a building and nothing useful yet. But it also does the default robot take turn. So the evaporator, despite not being used at all yet, when we do decide to use it, it'll already have like the columns and stuff like that set up. That's set up for all robots. And yeah, until we write evaporator specific code, we don't even need to do anything with it. It's just totally fine. And same thing with refineries. And so we could have left these both just as buildings and not even bothered making a evaporator or refinery class. It actually doesn't matter right now. It's going to be the same behavior either way because all it does is the default building activity. I just like to create them ahead of time so that if you see someone on your team has like edited evaporator.java or something like that, then you know that they're actually implementing some evaporator specific behavior. So let's just go ahead and do the same thing for refinery. And, oh, not X. So we'll call this one refinery. And we can save this as refinery.java. Great, and then we can go back to robot player and put that in here. Where is it? Refinery. Okay. So great. Those are sort of the major things that I wanted to talk about today. Does anyone have any questions about anything so far? All right. Would it be useful for me to do another one, or should we just split, do office hours, debugging, stuff like that? Okay, actually, how about we do it this way? Does anyone have, like, is anyone here for debugging? Like, do you have a question that you want to come up and ask me afterwards or something like that? All right. Then what I'm going to do is I'm going to stop lecture here. We'll do that. I'll implement the rest of them. It's going to be the exact same as minor, but with buildings instead of units and stuff like that. So I'll implement the rest of that tonight. Push it to lecture player, so that if you want to do a little bit of post-sprint reorganization, you can use that as a template. And yeah, there's no lecture tomorrow because we'll probably still be streaming the sprint tournament during lecture hours. We will probably say where we're streaming from so that you can like come and watch live if you want to. And like maybe there will be food, we haven't decided yet. But yeah, so sprint tournament tomorrow, so no lecture, but we may publicize a location to watch that live. All right. Hope that helps, and see you tomorrow.